Hi everyone, we are now in section 7.3, Annuities, on page 79. Your textbook page for this is 258 is where it starts. I really encourage you to make sure you read through that. Basically, the short version is that now you're not just having the bank compound your interest. The bank is active, but you're also active. You are depositing money every time, or sometimes it's a withdrawal. The first part of this 7.3, we're going to be saving up for something, and then in the next section we'll be paying off something, or we have some money set aside that we're going to be drawing out of, like a retirement of some sort. Instead of building up to the retirement, it's there and we're pulling out of it. So do read through your book carefully. The formula is getting more complicated, so I do want to walk you through how to do the calculator, although that is also in your textbook. One thing to note, that the symbols are all pretty much the same, except now we have this subtract 1 here. We have D instead of the P sub 0, but it's similar. It's just that it's a periodic deposit or withdrawal. It could be. So it's a little different. It's not the one lump sum. So everything else is the same, except now we're dividing by the R divided by K, the periodic rate, but the rest is pretty much the same. One other thing I want you to think about, if you want to go through the book and look through how this formula was derived, that's up to you. There's also in the extra help videos, you can check those out later, but it's not really necessary. It just shows you how it builds. And if you haven't had a higher math class, you're not probably going to be able to follow along with the math on that. Another thing I want to point out here too, if the compounding frequency is not explicitly stated, assume there are the same number of compounds in a year as there are deposits made in a year. So just be aware of that. The formula is always good to write with each problem. However, I wrote it on a piece of paper so I can move it around. You might want to do that too, just to have it handy, because it's up a little higher than I want it to be, and I want you to see it as I work through the problem. So here we have a more conservative investment account pays 3% interest. If $5 is deposited each day into this account, how much is in the account after 10 years? How much is interest earned, or in interest earned? And this is not just the I equals PRT version of simple interest. We have a lot more going on. It's a lot more complicated. So the total interest will be whatever you've deposited, the difference between that and what you actually ended up with. So I'll go through that. We'll need to figure that out a little more carefully. So I want you to try to pick out all the different pieces that would fit into the formula. The thing we're trying to find is the D. So when you look at this too, you want to pick up a few differences here from what compounded, just regular compound interest is. And the key thing is that it says $5 is deposited each day into this account. Okay, and sorry, we're finding P sub n on this one and D on the next one. So we are going to definitely need this formula for it's kind of a future value of an annuity. We could look at it as, what are we trying to save up for? So go ahead and try to plug everything into the formula, and I will do the same. Okay, so I'm going to walk you through how to type this all into your calculator. A few things to note here. You don't have to put parentheses around this because order of operations would say do that first, but if it helps you to remember if you're typing into your calculator that way, you want to do that. Also up here you could. Not necessary because order of operations would say do it, but we can add them in just for helping us along in remembering. And I'm going to jot down the in-between steps there too. Now I'm going to get rid of this out of the way. Okay, so we have calculator here, and I'm going to start here with the 0.03 divided by the 365. Okay, and I get 0.000082, so on and so forth. So I'm going to leave that right there in my calculator, and I'm going to then now add the 1. And that's the number I get. Then I'm going to raise that up to the exponent here. I could use parentheses and do 10 times 365, but it's easy enough to just do that in my head. And so now I'm at 1.34, so on and so forth. And I'm going to go ahead and jot that number down just over here. And before I do that, actually, I'm going to take and subtract the 1. And so I have 0.3498, so on and so forth, all divided by the 0.03 over 365. Don't forget that. So now from here, we want to multiply by 5. So I'm not going to clear out my calculator. I'm just going to hit times 5. And I get 1.7492, so on and so forth. So make sure you're matching up to that. And again, just leave that right in your calculator. And you can then simply hit the divide key and parentheses 0.03 divided by 365. It is really important to enter the parentheses into your calculator, even if you didn't have them written here on the paper. Your calculator does not know necessarily how that should work. It would divide by 0.03 instead of 0.03 divided by 365. So now we get 21282. So I'm going to go ahead and just write that out. I'm going to round to the nearest cent. So we have $21,282.06. Okay, so that's an approximation. So that's what he will have once he saves that up. Now we need to finish the problem. The second part says how much interest is earned. There's not too much room to fit that, but we don't need too much, so I'll squeeze that in down there. What I want you to do is just intuitively think of what that means and just pause the video and see if you can kind of hash it out, and then I'll write down the formula. Okay, so I have this set up here. Cumulative interest earned would equal P sub n, so it's whatever we're ending up with for our total value that we would take out of the bank, minus the deposits times the number of compounding periods overall. So we would want to multiply our time in years times the number of compounds in a year. So for our problem, that was $5 a day at 365. So we would end up having 5 times 365 times the 10 years. So we end up getting $18,250 was what we actually paid in. So if you just think of it that way, and then you can just leave that right in your calculator. Take your $21,282.06 minus that answer, and you should get $3,032.06 earned in interest. Okay, so that's the answer to this second piece. So make sure, especially on your paper quiz that you'll have at the end of the unit, you do want to make sure that you've answered all parts of the question. So next is example 7.7. That this one is just a little trickier because we have to solve for D, so typing things in might be a challenge, but I want you to try it as a classwork. So do that, pause the video, and just get it done right now. Remember, I want all the video notes that you just wrote up just now with me, or, you know, as we pause and you try them. So however it happens, I do want you to submit all the problems from the workbook. Not the textbook examples, but the workbook. So Mr. DJ needs $3,000 in 2 years to purchase a fancy new stereo system. How much should Mr. DJ deposit into an account each quarter? So there's our clue that he's making periodic deposits. So it's an annuity, not just the regular compound interest. And it's 8% compounded quarterly, so we do need to adjust. That's our R, that's our K. Remember, K is the number of compounds in 1 year, so think about quarterly would be 4. So go ahead and try to plug all that stuff into the formula that we've been using. This one, when we're saving up for something, we end up subtracting 1 off. It's a little easier. We have just a positive exponent here. But remember, it's a little more complicated than the regular compound interest. So you're going to have to use your parentheses, work your math carefully, try to use that answer key to keep everything in the calculator so you do not get rounding error. So this is how you should plug everything in. It's nice that this 0.08 divided by 4 will terminate, so it makes it easier to work with. But I'm going to walk through the steps on the calculator just real quickly. So I'm just going to kind of push this over here. But I have, and you don't need to write as many steps as I do, but I would start here, 0.08 divided by 4, and then add your 1, and then hit equal. You could just type in 1.02 for this one, and then raise it to 2 times 4 using parentheses, or just do 8. Then don't forget to subtract the 1 for this formula. We always want to subtract 1. So now I have 0.17, so on and so forth. And there's some in-between steps that you can just look at in the solutions later if you want. But I'm going to go ahead and do this, just leave that in my calculator, and I'm going to hit divided by 0.02. Just showing this out because I know a lot of times this is a sticking point for students, even in face-to-face class. So online, it's good to see how it's done out. So now I get this value here, which I need to divide both sides by that. That's what I wrote here in red in order to solve for D. So just a little bit of algebra there. And so on this, I'm just going to hit the 3,000. And hope I got an extra 0 in there that I don't need. So to get rid of that, I can use this little key there and hit delete so I don't have to redo everything. If I did have to clear, it would go up to the next line. And my answer would still be held from before. So then I have divide by and then second answer to get this 8 point so on and so forth. And hit enter and you get $349.53. And then make sure you do write it in a sentence. So that's the answer for that classwork. We'll stop there for this set and start another video for the next.